Hello, welcome back. We're in Algebra 2, Chapter 7, Section 3. This is page 3 of the notes, the last page. We have this checkpoint, number 5. We have to graph this function. And they give us a nice function to graph. But first, I'm going to recommend that we graph the slightly simpler function, y equals 2e to the 0.7x. Now, I want to highlight a couple things. First of all, the number 2 is greater than 0, and the number 0.7 that we're multiplying by is also greater than 0. Excuse me. Wow, I wrote greater than 2 for the first one. That's silly. Anyway, wow, did it again. Okay, boom. Both the coefficient and the number multiplying by the x are greater than 0, and so we know that it's exponential growth. So we know the general shape based on that information. Now, if we plug in a couple of points, we could probably start with the number 0. If you substitute 0 into this simpler function, you do 0.7 times 0 is 0, e to the 0 is 1, 1 times 2 is 2, so you have the point 0, 2, and then if you plug in the point 1, you'll end up with about 4. 0.7 times 1 is 0.7, and then if you substitute it all around, you end up with about 4. So, going to the graph, we have the point 0, 2 and 1, 4. And we can go ahead and draw ourselves an exponential growth curve based on that. Remember that our asymptote is apparently on the x-axis because all asymptotes begin on the x-axis for our exponential functions. Now, for the actual graph, which they asked us for, which is 2e to the 0.7x plus 3, basically we're going to take and we're going to move it up 3. So our points are going to be 0, well, instead it was 2, so now it's 5, and 1, it used to be 4, so now it's 7. Boom. 0, 5, 1, 7. So 0, 5, 1, 7-ish. And go ahead and make ourselves our exponential curve based on that. On the left, you might be a little careful. You go, oh, wait. I went up 3, so my new asymptote is at 3. So now I know where to go down to. It asked us to state the domain and the range. It's always fun at the end. The domain, you're probably guessing already, all real numbers. Boom. The domain is all real numbers. The range is a little more interesting. You have to look at your graph and your asymptote a little bit. Y is greater than 3 because it's all the numbers above the asymptote. Now, if we go ahead and look at the next box, it's not graphs anymore, continuously compounded interest. And there's a different formula than before, and it's A equals P times E to the RT. People like to call it PERT, and that's fine, but you need to remember that R and T are in the exponent, and you're fine. P is the principal. This is the same as compounded interest before. Principal means the amount you started with, just like it did back in section 7.1. R is the interest rate. Just like it was before. However, you have to remember to turn R into a decimal, just like before. So, next, we have an example that works with this. It says you deposit $3,500 in an account that pays 4% annual interest, compounded continuously. What is the balance after 1 year? Well, they helpfully remind you of the formula. So our principal is $3,500. E is, well, to be honest, E is E. R is 0.04. And T is time, so we have 1 year. Boom. And you put that in a calculator, and you get $3,642.84. So the balance after 1 year is, maybe put a decimal sign and a dollar sign on it just to make it look good. $3,642.84. Boom. Quick calculator work using our new formula. This is the easiest one we've had in quite some time, so try not to let this one intimidate you. Finally, we have a checkpoint based on the same thing. You deposit $4,800 in an account that pays 6.5% annual interest, compounded continuously. What is the balance after 3 years? Okay, well, we know the formula, which is A equals the principal times E to the RT. And so we'll go ahead and substitute in the amounts we have. We have A equals 4,800 is the principal, the amount of money going in. E is E. It's not a variable, it's a number. Sorry, still true. R is 0.065. And T is 3, because it's 3 years. Throw that all into a calculator, and you'll get 5,833.49-ish, to the nearest cent. So our answer is $5,833 and boom, 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 49 cents. That's the end of page 3. That's the end of the notes for this section. Thank you for watching.